Okay. Let's do a little bit of an odd problem. So you're walking along. There's this block. All right, and yeah. So you're over here, and you want to get over to here. And this block has a nice feature that there's actually a little path going back here. All right, and so basically you realize that this is a 32 feet. Why not? Or 32 yards? I don't know. Probably still too small. Whatever, doesn't matter. 32 something. It is what it is. And that just from somehow the geometry of the block, maybe there's more houses, like 8 more houses on the one side than the other. Well, it's going to be a lot more than 32 feet. Whatever. You realize that basically, if I call this x, and this is 8, and then this is x. All right, so that's kind of our setup. I don't know how you'd know the plus 8, really, but maybe. Anyway, it leads to an interesting little quadratic problem. Okay, and so what do we need to do? We need to figure out this x, right? So what tool do we have? Well, we've got the Pythagorean Theorem that says the square of the hypotenuse, c squared, is equal to a squared plus b squared. So a, b, and c. So 32 squared is equal to x squared plus x plus 8 squared. All right. So what can we do? What can we do? All right, we can try to solve for x algebraically, graphically, maybe try the quadratic formula, sort of the algebraic in there, but and then also play with triangles. Okay. All right. So and then could also do a guess and check. All right. So let's try the guess and check. All right. So over here, I've got my graphing calculator. I've set this up. So I've got x squared plus x plus 8 squared minus 32 squared. So I'm solving it for equal to 0. I find that's sort of easier, particularly as I don't want to square out 32. And to facilitate guessing, you can go to the table thing on this thing. It's kind of handy. And you can just start typing in guesses. So if I type in 1, minus 942. Now I want 0. So that's not good. I'm pretty far away. Let me try 10. 10 is minus 600. So I went from 942 to 600. So that's a sort of a 300 change. I need to do that again. So 2 more times. So 10 plus 20. So let's try 30. 1320. Okay, that was a little too much. So I went from, so there's 600 and then 1300, let's say 1200, 600, It's one step, and then 2 more steps led to this. And so I'm going to want to do 1 step from 10. That divide. So I'm going from 10 to 30, it's the size of 20. Let's say 21. Divide that up into thirds, so 7. So 10 plus 7 is 17. Why? Because I want to do that 1 step from 10 that corresponds to going from like 600, hopefully, to 0. And then another couple steps as got to the 1200, too far, right? So 1 step out of these, kind of imagine these 3 steps. And this is sort of rise, run, linear kind of thinking, but just sort of saying it half. Wait, anyway, 17 minus 110. Ooh, that's looking a lot better. We still need to go higher. So let's just try 19. So there's 2 away. And so now it's 110 and 66. So roughly 2 steps from 17 and 1 step from 19 is where I kind of want to go. So there's a 2. So I want to go down 1/3 of 2 from 19. So what is that? That's 18 point, say 3. Wow. All right, 2.58. That's looking pretty good. So that's a little bit too much still. So 18.2. Let's just get a bearing there. Whoa. Okay. So that's 3 versus 6. So maybe 18.27. Something like that. Okay, that's pretty good. Still a little shy of it. So oops, sorry, 18.271. There we go. And you can just delete those annoying ones. Right. So basically 18.27 would be the answer. So that's, I wrote down an equation, right? I wrote down what I'm trying to solve, and then I'm just guessing and checking, right? Just boom, 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 boom. And I get an answer without too much effort, without too much thinking, right? Too much algebra. The main algebra was converting it into an equation that I could then look at. That's the hard part, right? Taking what is the reality of it and modeling it into an equation. Once I get the equation, it's actually fairly easy to get some kind of solution. I just keep kind of iterating like this. Quadratics are very nicely behaved in this regard, so mileage may vary, but whatever. Let's also check over in GeoGebra. So we are looking for a triangle with hypotenuse length 32, so it's a right triangle, and the one leg is 8 more than the other, right? Those are the constraints. So if I go into GeoGebra, I can do a circle. The origin radius 32. All right, I don't even see that. Oops. Go back to the pointer. So here's my circle, and basically I need the hypotenuse to reach this circle, whatever this triangle I'm going to make. So now I've got a point on the x-axis here, and what I want is a point, so the third vertex, so it's going to be A, B, that base, and then a third vertex C, which is at the same x location as B, and that's the length of that side, so it's got the same height with an extra 8. And so basically, I can just draw on this triangle. I don't really need it, but whatever. Put this triangle here. And now I just drag this thing until it intersects the circle. And what do we have? B is now around 18.29, which is close to what we had before. It's a little, I guess, higher. Having a hard time. Well, high precision isn't really there, but you know, roughly speaking, that's what it looks like. Okay, easy peasy. And while we're here, we could also graph around with the parabola that we had. Okay. And then we wanted y equals 32 squared. You gotta zoom out, which you can do. Then do intersection point of these two things. And you get a point, 18.27. All right, so there you go. Now, what else can we do? Well, we can do this algebraically. That's always fun. Now, if I'm doing this, I mean, because of the stuff I just did, I know that 32 squared is 1024, but I'm going to attempt not to do all that. I just want to leave it as 32 squared because I'm lazy, theoretically. Well, I actually am lazy. So we got x squared, and we're going to have to square out that x plus 8 squared, right? So x8, so 64, 8x, 8x, x squared. Add them all together, x squared plus 16x plus 64. My answer equals to 2x squared plus 16x plus 64 equals 32 squared. So the first thing I notice is that everything's got a 2 in there as a factor, so I'm just going to divide by 2. So now we've got 32 times 16 equals x squared plus 8x plus 32. Now I've got 32 on the right, so I'm just going to, well, I guess I could first see what happens with this x squared plus 8x. So remember my little trick of x squared plus 8x. You can write that as x plus 8. And so 0 and minus 8, like so. And the vertex is going to be at minus 4. And minus 4 times 4 is minus 16. And so this thing is actually equal to x minus, plus 4. That's so that when I plug in minus 4, I get 0 in there. Square that. Subtract 16. Again, you can do the squaring of it. X squared plus 8x plus 16. 16's cancel, of course, and you're left with what you started with. Excellent. Now we plug this in, and what do we get? We get 32 times 16 equals x plus 4 squared minus 16 plus 32. All right, so I can combine that minus 16 with the 32 to get plus 16. And now I can subtract. So 32 times 16 minus 16 equals x plus 4 squared. Factor out the 16, so you have 32 minus 1, which is 16 times 31, equals x plus 4 squared. Almost there. Now we take a square root. So square root of this thing square root of 16 times 31 equals x plus 4. And theoretically it's plus or minus, but I know from this picture I'm going to want to be to the right of the vertex, so I'm just going to take the plus. It's minus 4 plus, now the square root of a squared times b is a times square root b. General fact. Assuming, well, actually that's probably just general fact. 4 times the square root of 31 equals x. Okay, and now what approximately is that? So this is 4 times minus 1 plus square root of 31. And what's the square root of 31? Well, 31 is halfway between 25 and 36, basically, right? Slightly closer to 36, so it's between, so the square root of 31 is between 5 and 6, slightly closer to 6, so maybe like, I don't know, maybe like 5.6. Subtract 1, you get 4.6, and 4 times 4.6 is something like 18.4. I've rounded, so it's probably a bit off. And how do I go home? I do second. Quit. Clear. What did I just say it was? It's 4 times minus 1 plus the square root of 31. 18.27105,745. So approximately 18.271. Alrighty. And now, in terms of if I wanted to use the quadratic formula, by the way, well, let's say we'll use this one. So A here is 1, B is 8, and C is 32 times 16 minus 32. I mean, so it's still this 16 times 31, I guess. No, wait, no, sorry. It's 32 times 16. All right, and so what would you have to do? Well, minus 8 plus or minus the square root. 8 squared is 64 minus, oh, and this is probably minus here, so it's going to be a plus. 4 times 32 times 16, all divided by 2. Okay, so that's some big number computations, not impossible. You can factor out from this square root basically factor out a 64. So this is 32 times 64. And what's the square root of 64? 8. 8 times the square root of, looks like 33. So, oh, right, sorry. There was a minus, so this was actually 15 or something. I don't know. It's kind of a mess. But, so what do I get for trying to scribble on the side here? Oh wait, no, sorry. That's 16. No, should be 31. It should come out right. As you can see, though, the quadratic formula leads to kind of an explosion a bit of the numbers, a little bit more than you need to. Keeping an eye on factoring and the square rooting and all that stuff can try to hopefully keep it down, but I feel like it's a little bit more work. Anyway, lots of options for solving this silly little problem. If I actually had to do it, I'd probably just model it with GeoGebra and drag the point around, because that was really